In order to get your gears brought into an assembly so that you could then grab a hold of a gear and spin it, or if you wanted to then go ahead and use a rotational drive constraint and have the gears spin on their own, we're going to walk you through that process right now. So to do that, we're going to have to open up a brand new assembly, and then we're going to have to go and get the gears so that we can place these gears into this assembly. So first I'm going to go ahead and I'll grab the shaft, and I'm going to need at least 2 of these. So I'll go ahead and drop 2 of those in my assembly. I'll go back, and I'm going to go ahead and grab the gear I just made, which is that 10 diameter 40 tooth, and we'll drop that in the assembly. And then the last thing I'll get is the first gear I made, which is that 5 diameter 20 tooth gear, and we'll drop this in the assembly as well. Now, in order to get these things to constrain and line up properly, I'm going to go right ahead and I'm going to turn on my origin plane so I can use these planes for alignment. I'm going to have these planes turned on. First thing I need to do is I'll get my shafts set up so that they're on the same plane. Right now, if I turn, I can see this plane and they're sort of floating up here. This one's floating down here. I'm going to want to align them to that. So I'm going to go ahead and grab my constraint tool, make sure it's on mate. I can grab my first shaft, align it to the plane, hit apply. I'll grab the second shaft and I will align that to the plane and then hit apply. Now I can go ahead and turn this. They are now set to this plane. They can still move, so we'll get them set up in position. Next thing I want to do is I actually want to get these gears to apply to the shafts so I can see the sketch geometry. I'm going to end up utilizing that sketch geometry later. So to do so, I'm going to go ahead and grab my joint constraint tool, and the joint constraint that I want is the rotational joint constraint. So I go ahead and select the rotational joint constraint. I'm going to slide in on the gear to ensure that what I'm going to select is going to be the front center hole of the gear, and then I want to go down here and I want to select the front face of the shaft as well so that those two would mate properly. Now that they've been set up and hit apply, I'm going to do the exact same thing again with my smaller gear and to the shaft and make sure those two get put together. Hit apply. Now the next thing I want to do is I'm going to turn this, and I can now see that my gear and my shaft have been put together and they are on plane, but there's nothing that's keeping the face fixed. So these faces will need to get fixed. I'm going to use this plane to do so. So I'll grab my constraint tool, my mate constraint, and I'm going to constrain this face to this particular plane. So now they've been set. Hit apply. I'll do the same thing again to this gear. I'll grab the face of the gear and then grab the plane. Now those are fixed in plane, and I can slide them back and forth this way, but I can't pull it away. So if I turn and look at this in my view cube directly from my right side, I cannot pull it away. I can't even pull it up or down because it's fixed to the shaft, to the original plane. Now what I did do is I moved them really far away from each other. So I'm going to go ahead and bring those back together here before I continue. All right. So now what I'm going to do is I need to get the spacing correct between the two gears, and that's going to be taken care of by my tangent constraint. Okay, it's still aligned. Go ahead and put these together using my tangent constraint. So I'll grab my constraint tool, and then what I want is the tangent constraint off of my selector bar here. So I grab the tangent constraint, and then I'll go ahead and I'm going to grab my pitch diameter of the first gear and then the pitch diameter of the second gear here. I'm going to actually turn this so you can see the me grabbing that pitch diameter a little bit better. And then they come together, and you can see how they are actually mating together right here. Go ahead and hit apply to that. Now they're still not set in any orientation, and I still can't see how they kind of move a little wildly. The reason why they kind of move wildly is because my shafts have not been grounded. I do not need to move the gears back and forth. The only thing that I'll have to do is rotate them. So I'm going to go ahead and select a shaft, right click, come down and ground the shaft, and I'm going to do that to both of my gears. So I'm going to select the other shaft, right click, and come down and ground that shaft as well. So now that they've been grounded, the only movement that I should be able to get out of these gears is a spinning motion. Now the thing now is I need to get these teeth to align to each other, and that's where I'm going to utilize the geometry on this gear that I've already put on this gear to find the center of the gear space and the center of the gear tooth. If you haven't done that yet, and you need to go ahead and do that, this gear doesn't have it, so I'll go ahead and do it here. I'm going to double click on the gear itself. It opens up that gear itself within the assembly, and then I'm going to go ahead and put a new sketch on that face. What I'll do next is then I'm going to project the geometry of a gear tooth, and I'll actually use a gear tooth and a gear space, and then I'll draw a line from one of the sides of the pitch diameter to the other side of the pitch diameter. If we do get a wild click like this, we just need to go ahead and do it again and make sure these are going to link up like that. Then I'll keep going. I'm going to go across the tooth as well because I may need to align in some other way here. I'm going to get the center of that gear tooth down to the center of my gear, and then I'll do it again from the center of the gear space down to the center of my gear as well. That way I can finish the sketch, I can return to the assembly, and now I can position the gear or the gear space directly to the plane. So I'll grab my constraint tool next. With the make constraint, I'll select the line of the tooth, and then I'm going to actually select the plane, and it then snaps to position. I'm going to remember this constraint because I'm going to have to either suppress it or I'm going to have to delete it. So next thing I'm going to do is I'm going to grab the solution mate again, and I'm going to grab the gear space and align that to the plane. By doing so, that has now aligned my teeth properly, and I can hit apply. I can hit cancel, and then I can go into the make constraint that I just placed, and I can delete that or suppress it. I'm going to go ahead and suppress that. Then I'm going to go up to the next diameter gear, and I will suppress that mate. What that does is it turns off the particular gear mating, but I want it there in case I ever need to get them aligned again. So I'm going to go ahead and I'm going to turn off my visibility for my planes, as they're not necessary at this point in time. And now I'm going to go ahead and get my rotation set up. So I'm going to go ahead and grab my constraint tool. I'm going to go to motion and then select the rotational motion, and then I need to select the reverse motion because the way that this gear spins in this direction, this gear will spin in the opposite direction. By doing so, I now need to set up what is the ratio between the two, and I go ahead and I place that information in here. So I'm going to just say 2 and then hit apply, and then I can hit cancel. So what should happen now is as I spin a gear, you can see the other gear spinning. Now, what it looks like to me is that because I selected this gear first and this gear second, the ratio is backwards. So what I'm going to do is I'm going to go in and I'm going to edit that ratio. So I will go in and I can right click, hit edit, and I can go in and change this ratio. So instead of making it 2, I'll make it 0.5. And now as I turn my gears, you can see that they are meshing properly. It has to do with what I selected first and second. If I go and select the rotational joint constraint and select drive, I can now tell it to start at the 0 angle and end at 360, and I should get a full rotation on my gears. With that set up, we can now finish the video